Okay, hello, I'm Jarno. Few questions before we start. I don't know, it's always the same silly start. How many of you have OT, Open Toolkit, installed on your laptop? Many people, okay. How many of you work for a CMS vendor? A few, okay. How many of you are under 30 years old? George! Okay. I hope you didn't feel offended by that question. There's a reason why I asked this. I wonder if I press... Yes. So I used to introduce myself as a coder. It's sort of diminutive, but that's not really what I do at Wunderdog, my employer. So what I do is I help customers solve problems, usually with technology. And this talk is a description of a project that solves a real problem that companies have. But thus far, it has really been just an excuse to use technologies I want to tinker with. So in that sense, this is one of those code first, ask questions later type of projects. Actually, just like the OT package registry last year, I started it off as a project to see what it would look like without thinking whether it actually makes any sense. So in that sense, it's the if you build it, they will come project. And I hope that happens here too. So in a way, in that vein, I'd like to first show you a thing, then maybe describe the thing, and then as the last step, maybe talk about why you might want that thing. What I'm describing here isn't particularly novel in the sense that every CMS vendor has solved this same problem at some point. Everyone who's bigger than that lone writer has done this. The unfortunate bit is that CCMS vendors don't really come to these presentations and describe their setup. They just keep that information to themselves because there are no open source CCMS vendors or CCMS products that are specific to DITA. So it's unfortunate that we're in an environment that doesn't have that much open source. But if you know of an open source DITA CMS, then just be more loud about it. So, yeah, I was trying to find a photo of a technical author using OT on their laptop, but like Googling for it and such. But that just didn't work because she was having a really bad OT day and had to go out for a walk to clear her head. So instead I got a photo of her cat who's doing an impression of a frustrated technical author. But what if I told her, and I'm telling you guys now, sorry, you now, that there is a way to run OT on someone else's computer. And not just your co-worker's laptop, because they went for lunch and forgot to lock their screen, but run it in the cloud, the cloud, the cloud, the cloud. And suddenly things start to look a lot better for our user, for our author. But it's actually quite boring. You just open a text file, write some JavaScript in there, run a command on the command line, and it's done. You can continue working as before, more or less. But boring things are good, especially after you turn 30. So, by the way, I didn't do a run-through, so I don't know if I'll be done in 5 minutes and you'll be able to go to the break, or if this will take an hour. So instead of trying to do a live demo, which always fails, I'll go with a simulated demo, and it's a simulated terminal up there. Okay. So in this demo, we first define a job or project that converts data, a data map, into a PDF. So we could do this same thing by just inputting all the arguments in a command line, but it makes way more sense to use this theoretical thing called project files to set up your project and your work. So in this file, cat, oh, it says cat. It just means that you print out something on the terminal. Yeah, so it's not related to cats. So we have a file called Thunderbird on our laptop. We still need to use laptops. We define a list of deliverables, and that deliverable defines a context with an input file. Unfortunately, that's a really long input file. What it says, it's a jar file, somewhere in GitHub, and I actually want to point to user_guide data map inside that jar file, or sorry, zip file. Then we want the output to be output into out directory, and then we have a publication that says trans-type PDF2 would be good. So fairly familiar concepts, just written down in a different way. Then I present you with a command line tool called Kuhnuri to run the previously described job. Some of you may have heard me mention the word Kuhnuri before. Its Finnish means drone, as in like a useless bee, the male bees. So it's basically a name I've used in this sphere to describe things that I'm experimenting with. It's not a real production quality tool yet. Just keeping the same name. So here's a help of that tool that you're not really interested in. So let's see what happens if we run it in a simulated environment. So if you run it, and if I had a video of the demo, you'd see a nice animated spinner going through all these steps. But because it would take a while and I don't know how to make videos, I think it's better just to view the results. So it's doing various steps, and you may notice that after submitting, it's doing queuing and converting twice. And that's not actually a copy-paste error. It's part of Kuhnuri's design, where we split things in a different way than your normal open toolkit might work. In this example, I'll go through it later on, but it's about converting data to FO first, and then in a separate step, you go from FO to PDF. Okay, so in a way, because we're no longer bound to open toolkit stack, the old stack of running and things work the familiar way, we can design or redesign some parts that make sense in a different type of environment. And we're talking about the cloud environment. And with cloud, that usually means that there are more than one computer involved. So you distribute the work. Also, one of the, I think, key things about cloud deployments is that the environments are not heterogeneous. So not all the computers are exactly the same. So some have a humongous amount of memory, some are really basic. So you might want to do is that you install some specific program on some, and then some have only generic setup. So if you take this in mind, or keep this in mind, we can take existing open toolkit trans types and reimagine them. Not completely reimagining them, but doing something different with the different environment. And what we could do is try and see if it makes sense to split some of those trans types and split them into 2 or more parts instead of having one simple process. So the terminology I use here is that we have a job which is doing something. That consists of 1 or more tasks, and those tasks are run by workers. So that's the terminology I'll be using. So in the traditional OT world, a job would be a trans type, something you run. Task would be a set of Ant targets that you've configured in your Ant build file, and a worker is the actual computer you're using, and it has some software installed. So, like I said in the previous example, we can split, for example, PDF2 into 2 steps, DITA to FO, FO to PDF. Yeah, and why would we want to do that? They have different characteristics. When you run the OT pre-processing, it's mostly reading XML, serializing XML, processing it with Saxon. And that has different characteristics than PDF formatting, which is usually CPU and memory bound. OT does a lot of reading, so in a way it's I/O bound in the sense of XML processing. So let me scroll a bit. Yep. So you might be able to see here now that it might make sense to split these 2 into different processes, because you could take the first step and run it on a worker that is sort of low end, doesn't have that much memory or CPU, and it has open toolkits installed. And that same worker could be converting, for example, HTML5, EPUB, Markdown, something generic. And then, because only some of your deliverables that you produce, only some of them actually require the PDF formatting, you could just have a single worker, a really high end with lots of memory and a CPU doing PDF formatting, for example, with Antenna House. And Antenna House is a commercial product that requires a license. So you just have that license on a single instance. So with that, workers, you should think of workers as they're specialized to do a given task and be really good at it. Yeah, I'm old school in that sense. There are really nice tools to write graphs of how things are implemented on AWS with 3D graphics and so forth, but I just found it easier to start drawing. And now the sun came out. Can you still see that? Barely. Okay. So this is the description of the stack I'm describing, the stack of Kuhneri's backend. All the magic happens in the center, in a AWS product called Batch. It's a system that runs workers, our workers, to complete your tasks. Oh dear. Oh, it's Radu. Yeah, Radu is behind the magic, yeah. It's always, he's so wonderful. So these are descriptions of AWS products. AWS meaning Amazon Web Services, sorry. Are they opening? No? Oh. And I lost something. Okay, now it's back. So Batch is the thing that actually does all the work. Batch includes a queuing functionality. that handles our queuing, because we want to be able to submit multiple jobs into our system and have them be processed in some order by priority. EC2 is a fancy Amazon term for a computer. Batch itself doesn't actually do the thing, it just batches them and forwards the actual work to EC2 product, which is a bunch of computers. So when EC2 starts to process your content, a new computer pops up and starts doing something. It doesn't have any data. So what it does, it actually goes to a thing called S3 up there to read the data. It's sort of an object storage where we can store our source data, content, our temporary files, our output files. Then we have a product called Lambda. You may have heard of a term called serverless. It's basically JavaScript files that act as if it were a server. That's the thing that controls our backend by accepting jobs from outside, saving the actual requests to somewhere, instructing batch to do the work, giving your users the state of the process, and so forth. Yet another product, DynamoDB, which is Amazon's database. We store the actual jobs we're processing and their state, and the state of the tasks. Then we have a thing called CloudWatch, which is a logging or log database. So you can get logs from various parts of the system and go and watch them. And then we have API Gateway, which sort of hooks up to the cloud in the sense that it allows us to give access to this system from outside AWS. So all of this happens inside AWS's environment, and then you expose some things through API Gateway to your end users. And in the bottom there's a thing called CloudFormation, which is a tool that orchestrates the deployment of this. Do these type of images look familiar to anyone? Some people, yeah. So basically DevOps, you develop code, but you have to actually deploy it somewhere. And the description of deployment of code looks a bit like this. So, when you build services on top of some cloud provider, in this case AWS, you have few ways of defining your stack. If you like manual work and you like your mouse, you like clicking on clickety-click things, AWS has a web console that is for you. So it allows you to go into the console with your web browser, allocate resources, create connections between those resources, and just visually, well, not kind of visually, create those. However, if you're a professional and you don't like manual work and you like reproducible results, then there's few technologies. I've used a nice AWS product called AWS Cloud Development Kit. It's a framework for defining cloud infrastructure in code, configuration as code. So you can write, for example, JavaScript or Go, they support multiple languages, to describe your deployment stack, how they're linked together, how those resources are provisioned, and so forth. So you can think of the CDK, Cloud Development Kit, as a library for a programming language and a CLI. So you write your custom code and using the CDK concepts and define your stack in code. Then you use the CDI CDI CLI, meaning command line tool, to deploy, update, destroy your stack. So it's not that much different from traditional configuration files, but with code, you have few additional benefits. You can test code. You can write tests for your code, whereas with configuration files you usually don't. You can use tools that support you in writing those things without specialized support for that configuration file. And then with code, you can also make that code configurable. Just like with OT, you have plugins. You can, in a way, create plugins for your deployment code. In this project, I wonder if I meant to leave the last line. Okay, so in this project I used a language called TypeScript, which is a superset of JavaScript with CDK, because TypeScript is strongly typed language, and I think if someone wants to experiment with this thing, it's quite easy to adopt to people who are not used to it. I think the learning curve for TypeScript is fairly low, not steep. What's the opposite of steep? Shallow. Shallow, that's a good word. And an additional benefit of CDK is, like I said, you can make it configurable, is that I'm able to write a description of how this will be deployed, share it with other people, and have other people easily deploy this type of setup in their own environment. And if you work for a CMS vendor, you already have this stuff done, but this is a description of one such project. Looking at code or a configuration file for this stack, it doesn't have that many options you can set. So in AWS there's a thing called a region, which means where in the world those computers will be located. For example, in Ireland or in Frankfurt. Then there's the account, because AWS is a commercial product. They actually want to charge you a bit, so you need an account with them. Those are generic stuff. But then we go into things that are sort of specific to OpenToolkit. We describe a set of jobs. Here you see probably familiar words. We define a job for HTML5, PDF2, some other PDF output. For each of these jobs, we specify the name of the worker we want to use, meaning sort of the name of the computer that will be used to run this, and then a bunch of parameters. Then, because I can't scroll due to this being simulated, that was a simulated scroll. So then we define the workers, the sort of the computers. In this case, we have a worker called basic, which just uses a Docker image called Jarno Elovirta, Elovirta / patch worker version 3.2. That's sort of a name of a Docker image, for those of you familiar with Docker. That's a worker that just implements your normal OpenToolkit processing. Then we have a custom worker. Again, it uses the same Docker image, but in addition you say, I want these plugins to be installed into that. Those are just normal OpenToolkit plugins. Okay. Normal OpenToolkit plugins installed using the ID through the package, plugin registry. Then we have a specialized FOP worker. That's not a worker that has Open Toolkit in it. It only does FOP processing. Then we have a graphics worker that does graphics conversion in a specialized worker that only does graphics conversion. Then something a bit more complex. We have a worker that only does antenna house processing. And because we only have antenna house license that allows us to use one CPU, we just tell the worker that you can only use one CPU because of the license constraints. And then we tell it, okay, we want 2 gigs of memory. And then we need to give it some assets, in this case, the license. Antenna House was nice enough to give me a trial license to sort of demo this. And I noticed that Antenna House already has their own Docker image. So I was able to use their base Docker image to do all of this. And it's really nice to see that companies or products other than Open Toolkit have their Docker images available to make this type of work easier. Then we have the last bit, which is a bit technical for me. What type of environment we will want to run this in. This is a spot instance type. So in AWS, you can sort of buy a computer and have it be available to you all the time. But it's constantly running, so you're paying for it, for the existence of your computer constantly. Then you have spot instances, which means if you're not doing anything during the weekend, you don't have computers available to you in your environment or the workers. And then on Monday morning, when the first person starts to run something, suddenly you get a spot instance. They'll just take some computer from the AWS universe and give it to you for some time. And then Monday afternoon, things start to slow down, no one's doing anything, the computer goes away. So with AWS you have to think about what things will cost, because they're not giving you that much for free. So these type of things you need to also consider when moving to the cloud. That's how you deploy it. You run a single command, and for me, that's magic. I don't have the output for this because it logs a lot, so it's telling you what it's doing. But you can start off from having nothing in AWS, and it will set up everything for you and have it available to use with a single command. And I think that's really cool. That's one of the nice things about CDK. I don't want to go into the details how CDK does it, but it's equivalent of magic. Yeah. If I have time, I have no idea how much time I have. Have I run out of time already? Oh, expletive. I'm really sorry. I do have sort of examples. Okay, let's see what I still have here. Oh, the reasons. I have loads of these. So this is sort of a difficult slide for me because for my work, I don't really have to think about money. There are other people in my company and my customer's company who are called managers or business who make these calls. But this is quite important. So one way of thinking about this is that you could combine all your services or resources into a single thing. So instead of having Open Toolkit be on every one of your users' laptop, you combine everything into a single thing. That means you can give them really old and obsolete computers because OT doesn't need to run on their laptops anymore, and you don't have to have fast computers. That saves money, right? it's a good idea from a business perspective. Okay. Then another one. Do you want to give each of your writers or users a separate desktop user license, or buy a single server license and have everyone use the same license? Because your end users will likely not be using that license during the weekend or in the evening. But with a cloud deployment, you're able to have a single license be sort of used all the time. If your user doesn't actually need that result immediately, you can just queue it to be run during the night. So it saves money. I have to fast forward this. This is basically describing the reasons to use a CI/CD system. And if you build a product like a CCMS that's on the cloud, you actually need this type of thing. You can't have people use your wonderful CMS, and then when they want to publish, they download the zip file and start doing something on their machine. You need to automate this. Okay, so if you're a coder, this would help you because you no longer need to maintain your users' sort of installations or workstations. So you update your transformations in a single place and everything will work out of the box for them. Other thing is that sometimes you would like to use tools that are not just Java. They might want to run something that is written in Haskell or Python. This is an easier way because you can just install that special processing environment in one place, and your end users will not have to install Haskell separately, or for example Python. And then you can run multiple versions of Open Toolkit with ease. You can just install different workers with different versions of Open Toolkit and have all those work sort of at the same time, which means you're able to stay on 1.x indefinitely. And that's a duck. It's a joke from a really good movie. So, so now you probably have a question.
I forget the question I was supposed to ask you. Did you write this on your hand, or? So, we rehearsed this because we figured no one would ask questions, and looked like that's the case. So, but we didn't rehearse it well, did we? No. Okay. So you can already do this with Jenkins, right?
Yes, you could do this with Jenkins, but do you really want to build your production system on top of Jenkins?
Oh, right. No.
Okay. So I'm really like over time, but deploying OT on the cloud will lead to happiness. Your belly will be full and your heart will be full of love. It's actually quite easy. I kind of showed you the way to do it, but it requires very little code. It's not free. You have to pay for it. AWS is a commercial company. But if you do the math, you might end up in a situation where this will make sense. And you can build or add value to your service with this type of thing. Yes, I don't have any more slides. I hope you don't have any questions. I would still like to show you just one small demo type of thing to prove that this works. So this is the PDF2 output you get from using Kuhnuri, using Antenna House. I can prove it. Wait. Silly cursor. Where's the cursor? Okay, it's there. It's there. Okay. See, it says Antenna House. Okay, and then we have another PDF generated from the same output using HTML5, styled with CSS, rendered with VisiPrint, which is an implementation of CSS renderer written in Python. And it looks different, but they both work. If you're interested, I can show you screenshots of what the resources look in AWS console, but that's not really interesting in the end. The takeaway is that cloud deployment is really easy. Thank you.